Hi everyone, welcome back. I'll continue rectilinear figures. Let's do sums from the exercise question number 14. Question number 14 is you have a figure ABCD is a parallelogram. X is midpoint of BC. The line AX produced meets DC produced at Q, such that you get ABPQ as a parallelogram. Prove that triangles are congruent. So you have a diagram given for the question. ABCD is a parallelogram. It is produced such that it meets at Q and P. X is the midpoint. X is the midpoint of BC, means these two sides are equal. You have parallel lines here. Question says that prove triangle. So write in triangle ABX and triangle QCX. You need to prove these two triangles congruent, ABX and QCX. We can easily prove this one using the property of congruency. First one, we write angle AXB. AXB is equal to angle CXQ, vertically opposite angles. Second one, we can write BX is equal to XC. X is midpoint of BC. And third one, we can use angle here. Angle ABX is equal to angle ABX is equal to angle QCX. And these two angles are alternate opposite angles, because this line AB is parallel to CQ and it is a transversal. Therefore, triangle ABX is congruent to triangle QCX by angle side angle property of congruency. Second part. Question says that prove DC equal to CQ equal to QP. So in order to prove this, we take property of parallelogram. You can do one more calculation here. Since the triangles are congruent to each other, we can write AB is equal to CQ. CPCT, corresponding parts of congruent triangles. Then you proceed with calculation. AB is equal to DC. Why they are equal? Because they are opposite sides of parallelogram ABCD. Similarly, we can write AB is equal to QP, opposite sides of a parallelogram ABPQ. Since AB is equal to DC, AB equal to QP, therefore we substitute here. Instead of AB, we write DC equal to, we write CQ equal to QP. All these sides will be equal. So this is very simple to prove. First you take congruency and then prove they are equal. Question number 14b. Question number 14b again, it says that prove AQ equal to PQ. You have a parallelogram, diagonal AC, and you have QP here. So A, B, C, D, P, O, Q. You have a condition given in the question. AP equal to CQ. AP is equal to CQ. APU equal to CQ. Prove that AC and PQ bisect each other. So in order to prove this, what do? We use these two triangles to prove they are congruent. And when you can prove these two triangles are congruent, you can easily write corresponding sides equal and then bisector in triangle APO and triangle APO and triangle COQ. First one, vertically opposite angles are equal. So you write angle AOP is equal to angle COQ. Vertically opposite angles equal. Then you can take this. These two angles are alternate opposite angles, or you can take this one. Okay, let's take this one. Angle OPA is equal to angle OQC, alternate opposite angles, because this PQ is transversal. Third one, it's given in the question, AP is equal to QC. Therefore, triangle APO is congruent to triangle COQ by angle side. Property of congruency, or you can write angle side angle side angle side. Then once you prove these two triangles are congruent, you can use the property and write AO is equal to OC CPCD. Similarly, you can write PO is equal to OQ CPCT. And since they are equal in magnitude, therefore AC and PQ bisect each other. They have same length, means they are getting bisected by themselves. Simple proving. Question number 22. Look at question number 22 now. I'll do 22 part A. You can try 22 part B yourself. It's not difficult. Parallelogram. Another parallelogram. Question says that prove CDEF. So name it as A, B, C, D, E. and F is a parallelogram, and you can easily prove it. Now look at this one, how to prove it. AB is parallel to CD because ABCD is a parallelogram. Similarly, you can write AB is parallel to EF. ABFE is a parallelogram. Since AB is parallel to CD, AB is parallel to EF, therefore you can write DC is parallel to EF. And once you get DC parallel to EF, two sides are parallel and equal, therefore DCFE is a parallelogram. Proved. Not difficult. This side is parallel to this is parallel to this, so DC will be parallel to EF. Once two sides are parallel and equal, you can prove this whole figure is a parallelogram. Then question says that second part, FD. So this maybe I made it wrong. It should be E and F here. So DCEF is a parallelogram. DCEF is a parallelogram. Second part question says that FT is equal to EC. You have to prove these two sides are equal. Since DCEF is a parallelogram, therefore directly you can write DF is equal to CE. When you have parallelogram, opposite sides are parallel and equal. From first only you get the proving. Third part question says that triangle. Prove that triangle AFD is congruent to triangle BEC. AFD and BEC. This one, these two triangles, you have to prove that they are congruent. Look at the first one. We can assume AD is equal to, side AD is equal to BC, opposite sides of parallelogram ABCD. Second one, similarly, AF is equal to BE, opposite sides of parallelogram ABEF. Third one, DF is equal to CE, opposite sides of parallelogram DCEF, which we have already proved. Side, side, side. Therefore, triangle AFD is congruent to triangle BEC by side, side, side. Property of congruency. Very simple sum. The last question from rectilinear figures. You have a rhombus. Rhombus is a four-sided figure in which opposite sides are equal. Diagonals intersect each other at right angle A, B, C and D. One of the angle is given. A is equal to 60 degree. This whole angle is equal to 60 degree. So what do? We take this, since angle A is equal to 60 degree. Angle ABD will also be equal to 60 degree. Angle ADB will also be equal to 60 degree. The reason is these two lines are parallel to each other. One angle is 60, so this entire angle will be equal to 120. And diagonal bisect the angle, so 120 divides by 2 is 60 degree. This angle you get 60 degree. And when you get this angle 60, 60 plus 60 is 120, you can calculate this angle, you get 60. And since all the angles are equal to 60 degree, therefore triangle ABD is equilateral. Equilateral triangle. And in an equilateral triangle, sides are equal to each other. So let AB is equal to BD is equal to AD equal to, we assume it as A. And once you know this sides, we use this triangle now. In triangle AOB, side we know A. This side is half of the diagonal BD. So length of OB will be equal to half of the entire length, that is A. So it is A divides by 2. We got A divides by 2. We got A. We do not know AO. So we use Pythagoras theorem for this to calculate the length AO. In triangle ABO, it is a right angle triangle because diagonals of rhombus intersect each other at right angle. By Pythagoras theorem, square of hypotenuse AB square is equal to BO square plus AO square. Hypotenuse square is equal to sum of square of other sides. It is A square equal to BO is A divides by 2 square. AO is unknown. A square equals to A square divides by 4 equal to plus AO square. Make AO the subject of formula. A square minus A square divides by 4 equal to AO square. Take LCM 4, you get 4A square minus A square equal to AO square. Therefore, AO square is equal to 3A square divides by 4. Length of AO is equal to root 3A square divides by 4, which can be written as root 3 by 2A. We know the side. Now question says that find the ratio. Find the ratio in which AC and BD we have in the figure. So if you look at the diagram, AC can be written as AO plus OC is to BD we write as it is. Lengths will be equal, so we have already calculated AO and OC, they are equal because diagonals intersect each other in equal halves. It can be written as 2AO because these two values are equal is to BD. 2 into AO we know root 3 divides by 2A is to BD we know length of BD is equal to A. 2 cancels, you get root 3A is to A. Cancel it, you get root 3 is to 1. This is the ratio. So please do practice questions from rectilinear figures, only parallelogram, rectangle, square and rhombus sums for the syllabus. Thank you very much. Stay safe.